Here we have this first example, all right? Now I'm expressing the function here basically as a sum of product terms. Now in this case I'm representing these product terms, of course, in their decimal form. So really the first part here is to really identify each square on the K-map and what basically decimal equivalent it has. Okay, so let's just quickly do that. 0 0 0 0, okay, whereby I'm talking about A being the most significant and D being the least significant. This would correspond to a 0 in this square. Okay, that would be decimal 0. 0 0 0 1, that would be decimal 1. This would be decimal 2. This would be decimal 3. This would be decimal 4, and then 5, 6, 7, and then we go down here. This is 1 0 0 0, so this would be decimal 8. This would be decimal 9. This would be 10, 11, and then of course this square would be 12. This one 13. This one would be 14. And this square over here, 15. So what we've done is we've identified then each of those squares with their decimal equivalent. Now what we'll do now is we'll plot these product terms then on the map. Now notice we have here some don't care terms. Now what we're saying in this particular problem is that basically we don't care if this were a product term that we could use, or this was, or this was, or this was. So we can, in this case, use these don't care product terms in the minimization process. But let's plot this first, okay? So we have a product term for 2. Let's represent that by a 1 sitting here. We have a product term for 4. Let's represent a 1 sitting here. We have a product term for 6. Let's represent that here. Product term for 7. A product term for 12. A product term for 15, okay? Now let's plot the don't care terms down. These are the don't cares. We have a don't care at 0, okay, so I'll put that down as a D. We have a don't care at 3, so there it is, don't care at 3. We have a don't care at 5, there it is. A don't care for 11, there it is. And a don't care for what? 13, there it is, okay? All right, now as I said to you before, we can use these don't cares in the minimization process. Now what we're trying to do is we're recognizing adjacencies. We're trying to group together, okay, the largest number of product terms. Now we can only go in what? Groups of 2, 4, 8, 16, etc. Okay? So let's have a look at this. What's the best we can really do here? Well, look, how about this here? I've got basically all of these squares. I could group all of these squares, including these don't care terms, together. Well, let's do that. That's grouped. All right? So let's write our function down. Our first product term then minimized is what? All right, now what we're going to do is we're going to look, if you like, vertically, and we're going to look to see what variables change. All right, well, they all change, okay? And then we're going to look horizontally. We're going to see what variables change or don't change. The variables that don't change would be CD. And so therefore the first product term is what? CD. All right. What else can we recognize on this map? Well, let's see. I'm grouping either in 2s, 4s, 8s. Well, how about these 4 here? Okay, I've got to cover all the 1s for sure. Okay. That's a requirement. Don't have to cover all the D's. If the D's don't help, I won't use them. So look, that gives me a grouping of 4 terms there. Okay, so what's this? Well, let's look vertically. What variable doesn't change as we move from, let's say, these 2 squares to these 2 squares, up and down? The only variable that doesn't change is what? B. So we'll write that down. That's B. Okay, as I move horizontally, what variable doesn't change? Okay, well, it's what? It's C bar, isn't it? Okay, so let's write that down. That's our product term then for this grouping, B, C bar. All right, so what else can we do? Well, I can grab these two ones together. Yeah, okay, that's good. But if I grab two ones together, the product term, the resulting product term, and you should try this, okay? The resulting product term would be 3 variables, okay? Can I get 4, a grouping of 4? Yes. Now, there's more than one way to go here. I could certainly get this grouping of 4. That's good. No problem with that. Or I could get this grouping of 4. That's no problem with that. Either one would be fine, okay? Well, look, let's take this grouping here and this grouping right here, all right? So how do we write down that product term? Well, look vertically. What variable doesn't change? Well, it's what? It's a bar. So we'll write that down, a bar. Well, as we move horizontally from there to there, what variable doesn't change? D bar, okay? We'll write that down. There it is, D bar. Okay, so here we have then, we've plotted this sum of products expression written in this form onto the map, we've recognized adjacencies, and we've minimized. Okay, let's have a look at this example. All right, once again, it's written in the same form, a sum of these product terms, and we're showing the product term by their decimal equivalent. All right. Here is a 5-variable map, okay? It's really 2 4-variable maps. We've got A, B, C, D, E, okay? Now we're assuming basically here that A is most significant and E is least significant, as we did before, okay? All right, you have to identify then each square's decimal equivalent. So we've done this before, but look, 0, 0, 0, 0, 0, well that would be the decimal equivalent of what? 0. So this square corresponds to a product term that has a decimal equivalent of 0. Okay? Take this one for an example. 0, 0, 0, 0, 1. Well, clearly that would be a product term that would have a correspondence of decimal number 1. Okay? And you could go through and verify that once again for yourself. All right? Okay, let's plot this. All right, I've got a product term here at 0. So we'll put that guy down. All right, there it is. I've got a product term at 1. There it is. I've got a product term at what? 2. There's the product term at 2. I've got a product term at 3. There it is at 3. Another product term at 8. So there's the product term at 8. Another one at 9. Good. Another one at 10. Another one at 11. Another one at 13. Okay, so let's put 13 down. There it is. Another one at 20. Okay, so we'll put 20 down. There it is. Another one at 21. There's the one at 21. 22. We've got one at 22. So let's put the one at 22 down. There it is. 23. There's the one at 23. And then 29. We've got another one sitting there at 29. All right? Once again, you're trying to group as many of these squares together as you can in basically groups of either 2, 4, 8, 16, etc. Okay? So you got to recognize adjacencies. Now, the interesting thing about a 5-variable map is if I look at this grouping here of 4, that's clearly a grouping of 4, so I'll circle this guy here. All right? If I have that exact same grouping on the E equals 1 map, okay, I eliminate the E variable, okay? And what I suggest you do is maybe pause at this point, okay? Write down the product term here, okay? And then write down the product term here, and you will see that if you combine by Boolean algebra those two, you will eliminate the E variable, okay? So really we're saying that this grouping is really adjacent to this. The only difference is that this is the E bar map, this is the E map over here. Okay, so since they occur in exactly the same place on both maps, I can eliminate that E variable. And if I write down my function now as being what? Let's look vertically. What's the variable that doesn't change? A bar. Okay, so we'll put down A bar. Okay, I look horizontally. What variable doesn't change? C bar. Okay, so I'll put down C bar. Okay, since it's on both maps, I don't need to include the E variable. What else can we do? Well, let's have a look here. No, well, clearly those two will group together. I can't group these. Yeah, those two are on this map, and they're on this map as well. So sure, I can get this grouping here. I can get it with this grouping right over here. Okay, since they're on both maps here, I eliminate the E variable. So, okay, let's write that product term down. Okay, so I look basically what? Vertically first. Okay, well, basically what? Both of those squares are represented by what? A, B bar. So let's write that down. A, B bar. Okay, and then as I move what? Horizontally, what's the variable that doesn't change? It would be C, wouldn't it? Yes, C. Okay, so that's dealt with that, and since it's on both maps, the E variable has been eliminated. Okay, not done yet. We've still got this guy here. What's the grouping I can get here? Well, yeah, I can just grab those two, and that's the best I can do. I'll grab those two right there. These two only appear on this map. They don't appear on this one. So let's write that product term down. All right, as we do this, what have we got? Looking vertically, the only variable that doesn't change would be B. So let's write B down. And as I look horizontally, well, it's really these two squares correspond to what? C, D bar. So it's really C, D bar. Okay, and that's the best we can do for that particular example. Okay? All right, let's have a look at this third example here. Now we're given basically a function, sum of product form, all right? But now we're being given this in terms of Boolean variables. Okay, so we're going to plot each one of these terms on this map, and we're going to see if indeed we can minimize. All right, so let's go ahead and plot the first term right here. Okay, which is what? A, B, D. A, B, D. Okay, so how do we do that? All right, we're looking where A is true. All right, so in fact we're looking where AB is true, since we'll look down here, the vertical section. Where's AB true? AB is true here, okay? In fact, all of these squares are true for AB, yes? But we're looking for where AB is true and D is true, okay? So where's D true? Well, let's see, D is true here and here. So really where we've got AB true and D true, it would really be just this square and really this square here. So we'll put that down, that square and that square. That's our first product term plotted. All right, now let's look at this guy. We're looking for where B is true and where C and D are true. Well, where's B true? Let's have a look at where B is true. Well, looking along here, well, B is true here, B is a 1 here, B is a 1 here. Okay, so we're looking really at those two now. Okay. All right, now where is C and D true? C and D. Well, C and D is true really for the whole row, but we're looking for where we've got B true and C and D true. So really it's just this square here and this square here. All right. Last case, we're looking now what? Where B bar is true and where D bar is true. Well, where's B bar true? Well, as I look down here, this is B bar, this is B bar, so B bar is true here and here, so let's note that. B bar, true. Now, but I'm looking for where D bar is true as well. Now, there's D bar, okay, there is D bar, so we want B bar and D bar, so basically we need a term here, a term here, a term here, and a term here. Okay, so that's that function plotted. Now, can we do any better? Well, let's have a look at this. What could our grouping be? Well, I don't know. I mean, look, I can group these 4 ones together. We've just done that. We've just plotted that, okay? So certainly I can group those 4 ones. They're adjacent, and I can write my function down as being what? Well, if we were to read that off, we'll basically get this term here, which is what we've just plotted. But once again, if I'm looking vertically here, what doesn't change? B bar doesn't change, so you write that down. As I look from here to here, what variable doesn't change? Well, it's D bar doesn't change. Okay, fair enough. All right. Or, well, I can group this together as much as we had before. Okay, what's not changing here is what? B. And as I look here, I've got what? C, D. All right. Or this term here, which would be AB, and as I move from here to here, what variable doesn't change? It would be, of course, D. All right, so look, no improvement, no difference, but sometimes you don't know that. It can be very quick to plot it down and just see if you can indeed minimize, okay? Let's have a look at this example. Now, first of all, I'm going to say to you here that this is not in a sum of products form. You need to get it in a sum of products form. So how do you do that? Well, you expand it out. Okay, so let's do that. Okay, expanding this out, what do we have? We have A, look at this, we have A by what? A. A ended with A is what? So we'll write this function out, F. It's just A, isn't it? Or, let's continue. A going here to here, that's AB, isn't it? Yep, AB. Yeah. Around the other way, doesn't matter. Okay, what about from here to here? That's AD bar, isn't it? AD bar. So it's or AD bar. Okay? Alright, now what else have we got? We've got this one here, haven't we? Which is or. What would that be? AB bar. Okay, so that's AB bar. Okay, and then what else have we got? We've got B bar by B. What's B bar by B? Yeah, it's a 0, isn't it? Okay. Alright, then we've got this with this guy. So we're looking here now at that. What is that? That's B bar D bar. So it's or B bar D bar. Okay? Or, now what have we got here? We've got CA or AC. Okay. Then we've got what? C with B. So that's or CB. And then we've got C D bar. And then we've got a C D bar. Okay? Now, we could plot each one of those terms on a map. We could sure do that. Sometimes it's nice, though, to recognize, use a bit of Boolean algebra here and just recognize if I've got an A or other product terms which include A, okay, basically the result will just be A. And we can prove that. Look, this is equal to A. It's like factoring. Bring out the A, you've got one or. What's left here? B. Or. What's left here? D bar. Or. What's left over here? B bar. Okay, that's dealt with all the R's. Another A over here, isn't there? Or C. Close the bracket. Now what am I left with? Let's look at what you're left with here. Yes, you've got what this B bar D bar term. Or what else? What else? What else? Okay, you've got this CB term here. Or you've got what? C D bar. Okay. Now you know one or anything is just one, isn't it? One or anything is just one. And so this is really A then. That's one. And then or B bar, D bar, or CB or CD bar. Okay? And that's what we're going to try to plot on our map. And we'll see if we can actually minimize. Okay? Okay, right, let's give this a go. All right, so here is that function. We've already done some minimization then using Boolean algebra. Okay, so let's plot this. Let's plot A. Well, where is A true? Well, A is true here and here, so this whole row is where A is true. This whole row is where A is true, and we're only looking at the case where A is true. All right, so let's go ahead and plot that. We've got a product term here, 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 here. Okay, B bar D. Well, where is B bar D true? B bar D. Well, look, B bar is true here and here, all right? And where is D bar true? D bar is true here and here, okay? So we really have a 1 sitting here, 1 sitting here, 1 here, 1 here. Okay, then we're looking at what? C, B. Well, where is B true? There is B being true right here, isn't it? And what else are we looking at? We're looking at where C is true. Okay, well, where is C true in this case? All right, we're looking at where is C true. Well, look, C is true here and C is true here. So really, I've got a 1 sitting here and a 1 sitting here and a 1 sitting here and a 1 sitting right here. Okay? Are we done? Well, not quite. I'm looking at now where we've got C and D bar true. Now, where is C and D bar true? Okay? C and D bar true. Okay, well, there's C, there's D bar, so it's true here, 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 and here. Okay? Okay, so what's my best grouping here? All right, well, look, clearly I think A is good, isn't it? So we'll group A. So our function then is what? A. All right? Or, what else can we get with this? All right, remember trying to get the best that we can out of this, okay? That's what we're trying to do. All right, so let's think about this a little bit. Look, I can group these guys, can't I? That would probably be all right. Okay, so let's write that product term down. What have we got? B. So let's write that down as B, right? And what is common over here? C. Yep. Is that right? There is C common there. Or, now what else can I do? I've got to get this one and this one. Yeah, this grouping here, here, and here, and here. That would be about the best I can get. And I've covered all the ones. So what is this? All right, looking vertically, what is common? It is B bar, isn't it? And then looking this way, what is common? It would be D bar, okay? And that really is the best that we're going to really achieve really in that case, okay? Okay, let's look at this last one, and I'll let you actually finish this, but notice here that this is not in a sum of products form. Okay, we need to get it into a sum of products form. So how do we do that? Well, got a bar over the whole thing here and a bar over this. We're going to use De Morgan. And if you remember from De Morgan, if I had A, for example, or B with a bar over the whole thing, this is equivalent to what? A bar, B bar. And if I had AB with a bar over the whole thing, that's equivalent to what? A bar or B bar. And that's what we're going to apply to this over here. So if we apply this, and then sometimes it's useful to put brackets here so that you don't get confused. So let's deal with this first term over here. Our function then is what? Well, using De Morgan on that first term here, it's really just A bar, B bar, C bar. Okay, or now let's deal with what's in the bracket over here. You can even maintain the bracket. Okay, what does this come out to be? Well, this is really going to be what? Your A bar or B bar. And that's A bar or B bar term. Now you could lose the brackets at this point. F is our function A bar, B bar, C bar, or A bar or B bar. Okay, and I'll get you to plot that on a 3-variable map, and you'll see if indeed you can minimize. And also you may try Boolean algebra on that as well. Okay, that ends this section.